We good? All right. So 3 things. I really like 4 things, but even and odd degree polynomials. We want to talk about the leading coefficient, and we want to talk about end behavior. Okay, so if I look at this graph right here, this first graph right here, does anybody remember from last year how I can tell by looking at a graph whether a polynomial is even or odd degree? There's a way to tell this by simply looking at a graph. By simply looking at a graph. Chloe? Depending on where the maximum and minimum are. Not necessarily, because I could have a graph that has really high or like really low, and like that's not necessarily going to tell me whether it's even or odd. Cassandra?
I forgot which one is it, but I think you have either the roots from the R or the maximum and minimum.
So you can count the roots. The risk is sometimes there'll be imaginary roots that are not on here, and it's a little bit difficult to see. Lucio?
Wouldn't it be like the end behaviors of each?
Right? So explain that a little bit further.
So like if they're both like facing like down, like that'll be even degree, but like if they're doing opposite, then it'll be an odd degree.
Right. So if both ends are going the exact same way, that is an example of an even degree polynomial. So let's write this down. So even degree is that the ends go the same direction. So this would be an example of that. Another example would be something like this. Here both the ends go up, here both the ends go down. Questions? Now we also talked about something called the leading coefficient. Does anybody remember what that even means? Like what does the leading coefficient even mean from last year? Javier, what do you think?
Is the coefficient versus the first variable?
The coefficient in front of the first variable.
Like what was the biggest exponent?
There we go. So the leading coefficient is the number in front of the variable with the highest exponent. Sergio, are we getting both this and that? Because like it's really crucial that a lot of kids miss class.
Nope. No, we are.
Now we are? Okay, great. Thanks. Okay, so we know this is the leading coefficient. So an example would be the following. If you look at problem 2, the leading coefficient would be 4,023. Because that is the number in front of the biggest exponent. Questions on that? So leading coefficient is just the number in front of the highest exponent. So on problem number 3, take 25 seconds, think to yourself what the leading coefficient is. On problem number 3, take 25 seconds, think to yourself what is the leading coefficient. On the count of 3, everybody should shout it out. 1, 2, 3.
-4.
Very good. So -4, right, is the number in front of the highest, in front of the variable with the highest exponent. Now, how does the leading coefficient translate onto the graph? That's the next question, right? How can I look at the graph and determine something about the leading coefficient? Does anybody remember this? Javier, what do you think?
Well, I know how to find out the biggest the highest exponent, which is looking at how many maximums or minimums.
Not necessarily, because you could have the imaginary one. So not necessarily. That's not necessarily going to work every time. But how can I find the leading coefficient? What can I determine about the leading coefficient looking at graphs? There's something I can determine. Chloe? Which one? This one that I drew? Okay. Yeah. This may be the first time we have a student in our video. Is it, Sergio?
It probably is, yeah.
Except for like your face
My voice.
sometimes. Yeah, your voice. Yeah. Okay. So the distance between the max and min, that's not necessarily going to help us determine something about the a value. Michelle, you had your hand up?
I was going to say the most places when you say something is the
Number of like humps up and down? Not necessarily dulce?
it's going to be negative or positive.
How do we determine that?
Because if it's looking at the positive and if it's flipped, it's negative.
Okay, so like now we're making some progress. So so in this case, the leading coefficient is greater than 0. And in this case, the leading coefficient is less than 0. So if the positive side or the positive end is facing up, the leading coefficient is positive. So if the positive end is facing up, or is going up maybe, the LC, just leading coefficient, is positive. And alternatively, if the positive end is going down, the leading coefficient, LC, just leading coefficient, is negative. Dulce.
Doesn't it also determine the stretch?
Yeah, so it definitely does affect like how steep the graph is. That's right. Cassandra?
What do you mean by positive end?
Okay, great question. So by positive end we mean the right side of the graph. So when x goes to infinity, what happens to the graph? More questions. Okay, so let's look at number 4. So if you look at number 4 right here, does anybody still need this right here? Right here. Okay. So if you look at number 4, take a sec, think to yourselves, is number 4's graph even or odd? Think about what we just talked about. Is number 4's graph, think to yourself for a sec, even or odd? Sergio, what are you thinking?
I think it's odd.
You're thinking odd, and explain your thought process. Like why do you think it's odd?
You said the one on the positive side determines whether it's positive or negative. I mean, even or odd.
No. This the positive end only talks about leading coefficient. We're not there. We're talking about even or odd degree. Matthew?
Is it like wait, so you want to know if it's negative or
No, even or odd. Even or odd.
it's odd because it points in 2 different directions.
Right. So this is an odd degree polynomial because the ends go in different directions. This is an odd degree polynomial. So odd degree, the ends go in different directions. The ends go in different directions. So when you look at a graph, we should be able to tell right away whether it's even degree or odd degree, just by looking at the 2 ends. Now what about the leading coefficient? Take 20 seconds. Leading coefficient. Is the leading coefficient positive or negative? As you think about this, is the leading coefficient positive or negative? We're just looking at the graph. Is the leading coefficient going to be positive or negative? Daisy, what do you think?
I'm not sure. And it has to be the one with the largest coefficient.
Right, no, okay, but right, that is true, but we don't have a graph, sorry, we don't have an equation here, so I don't know what the largest exponent is. But how can I just, looking at the graph, determine what the leading coefficient is? So we said on the previous problem, we said if the positive end goes up, the leading coefficient is positive. Michelle, what do you think? Why is it going to be negative? What is it? Right. So here we have a negative leading coefficient because the positive side, when x goes to positive infinity, the graph goes downstairs. So the leading coefficient must be negative. Questions? Okay, those who are good, try number 5 on your own. Take 30 seconds on number 5, figuring out even or odd, positive or negative leading coefficient. If you have questions, let me know. Javier? We're not asking for the number. Yeah. Take a look. Take 30 seconds. All right. How many people, just like raise your hand and say this, how many people think that the degree is odd? How many people think the degree is even? And how many people have no idea? I appreciate the honesty, always. Somebody who said this was even, explain the thought process. Somebody said this was even. Melissa, explain the thought process.
Because both of the ends go in the same direction.
So therefore, is
It's
an even degree polynomial. How many people think that the leading coefficient is positive? How many people think the leading coefficient is negative? And how many people are unsure? I always appreciate the honesty. Victor Mendez, can you explain why is the leading coefficient positive?
Both sides go up.
Both sides go up? How does that? So that's a little bit. That's right, but a little bit too specific. Let's generalize, Javier.
It says positive end, which is on the right side.
Right.
Positive end goes up and the positive end is negative. If it goes down, it's negative, but if it's
So in this case, the positive end is going up. Therefore, the leading coefficient must be positive. Questions? Jessica, does that work? Does that make sense? Mr. Ramirez? Great. All right. Now, let me switch to the other board, so let's pause this. Lucio, you want to take this?